this is the check understanding with example 3 on page 369. Okay, multiply radical expressions. Okay, as you notice, we have two expressions here. All right, each one has something outside the radical and it has something inside the radical. Outside, inside. So as a first step, let's multiply together those things which are outside the radical. All right, 3 times 2 is 6. And then by the product property, we should be able to put together everything that's underneath the two radicals. So this is 7x to the third times 21x to the third y squared. You can simplify that. Let's 6 times the square root. 7 times 21 is 147. And that's x to the third times x to the third. Add the exponents, that's x to the sixth. And there's y squared. Okay, now we need to simplify the square root. 147 is not a perfect square. So we need to think of the largest factor, the largest perfect square, if there is one, that divides evenly into 147. And if you go down the list of the perfect squares, which we did on a previous slide, right, you would get to 7 squared equals 49. And if you check it out, 147 divided by 49 equals 3. We kind of knew that because we know this is 7 times 7 times 3. So it makes sense that we could do that. So let's say this is 6 times 49 times 3 times x to the 6th y squared. I can think of these as all a bunch of separate radicals. 6 times the square root of 49 times the square root of 3 times the square root of x to the 6th times the square root of y squared. Okay, how many of those simplify? Let's see. 6 times the square root of 49 is 7. The square root of 3 cannot be simplified. The square root of x to the 6th, well, 6 divided by 2, that means I can take out 3, and there's none left behind. Y squared, 2 divided by 2, that means I could take out 1. And now let's simplify this and put it all in the right format. That's 6 times 7, 42. X to the third y times the square root of 3.